Hey there, and welcome to this second video on foundation level mathematics. Still working within the topic of numbers. So this time we're looking at proportions. So last time we was looking more just at whole numbers. Now we're looking at more uh, fractional amounts, decimal amounts, that sort of thing. So let's take a look at today's lesson plan. So we've just got these four sections. You've got fractions, decimals, percentages, are three main types of proportion. We're going to look at each one of them individually and how they work and what exactly they are. And then finally look at conversion. So when we want to convert from one to another, because as we'll see, each one has their different uses, and sometimes we'll use one as opposed to another. It just works, better. So let's get started with fractions first of all. So fraction, something like this. We have a numerator, we have a denominator. So numerator is the number on top, denominator is the number on bottom, and it's essentially just a division. This is like 15 divided by 65. And rather than doing that division, we might leave it as a fraction like this. But then there are certain things we can do, like this one here, we might want to simplify. And what we mean by simplify is we want to try and make those numbers smaller, because at the moment they're bigger than they need to be. So what we do is we try and break up the numbers into factors and find a common factor between the two. So 15 we can put as 3 times 5. 65 we can put as 13 times 5. And you see there's that common factor of 5. And like I said, this is a division. It's 5 divided by 5 you essentially got going on there, which is 1. And times by 1 doesn't do anything. So we can cancel that out and we just get what's left over, which is the 3 over 13. And so that's simplifying the fraction because we're making the numbers smaller. Uh, Now, to look for those common factors, we have various divisibility laws we can use. Some of them you might be familiar with, others not. Something like this to see if numbers divisible by 2 is you need to see if it's even, whether that last digit is divisible by 2. You have, if the last digit is 0 or 5, it means the number is going to be divisible by 5. If the units digit, that last digit is a 0, then the number is going to be divisible by 10. So those ones I imagine you're quite familiar with. Here's one that's very useful that you might not be familiar with, which is if you add all the digits together, and if that sum is divisible by 3, then the original number is also divisible by 3. And then you have this one, which you might not need to use so often, but it's handy to know that when you add alternating digits and then find the difference between the two, if that is divisible by 11, then the original number is divisible by 11. And I've got a little example there for you to see how that works exactly. So here's some divisibility laws that we can kind of use to help us find common factors between numbers. So that's, for when we want to simplify. Sometimes we want to go in the other direction where we want to scale the numbers up and make them bigger. So say, if, for example, I wanted to get that bottom number to 63, what I could do is I could times it by 9, because 7 times 9 will get me 63. But as long as I multiply the top number also by 9, because you see here, what I'm essentially doing is I'm multiplying by 9 over 9, which is 1. And so multiplying by 1 doesn't make any difference. So I'm not actually changing the fraction here. It's still the same value. It's just the numbers look a bit different now. So that's how we can essentially scale a fraction up and down. So let's look at some arithmetic. So unlike with regular numbers, like, well, whole numbers, multiplication actually is a bit easier than addition and subtraction. So when it comes to multiplication, we can actually just multiply across the top and the bottom. Because this is like 6 divided by 11 times by 2 divided by 7. It's like the two things you're dividing come together and the two things you're multiplying at the top come together. That's kind of the way to think of it. And so, yeah, we can just do the top and the bottom individually and we'll get 12 over 77 like that. Division is also not very complicated. Like, so if we're doing 2 over 9 divided by 5 over 6, that second fraction that we're dividing by essentially just gets flipped upside down. It's what's known as the reciprocal. So, and the reason why that is because you think about it, it's like 5 over 6. It's like you're multiplying by 5 and divided by 6. But if you're dividing by that fraction, it's like swapping it around. Kind of like how we have a minus minus produces a plus. It's almost like a division produces multiplication. And so that's why it kind of flips. The 6 goes to the top and the 5 goes to the bottom. Um, but yeah, that's the rule in how we do that. That fraction you're dividing by is the one that gets flipped, and then it's just the same as before. It's now multiplying by that reciprocal, and we can do that just as we've done above. Now, Of course, whenever you get an answer, you always want to be looking to simplify that answer. Most questions will say leave your answer in its simplest form, but even if it doesn't, it is generally good practice to do that. And in this case, look, you see there's a common factor of 3 between 12 and 45. So cancel out that common factor of 3 and we'll get 4 over 15. So um, now let's look at, say, addition, which, like I said, is a little bit more complicated. We can't just add across the top and the bottom. It doesn't really work like that. What we need to do is get the two fractions to be out of the same amount, first of all. Like this is 1 out of 3. And then the second fraction is 5 out of 8. We kind of need them out of the same amount first. So what we need to do is get those denominators to essentially be the same. So kind of like what we saw on the previous slide. Um, where I'm going to scale each one up. So 3 and 8, I need to think of, right, what is a number that is divisible by both 3 and 8? The smallest one really is 24, which is basically if I do 3 times 8 or 8 times 3, as you can see here. So in that first fraction, I'm multiplying the top and bottom by 8. So I'm not changing the fraction because I'm doing the same thing to the top and bottom. And on the second fraction, I'm timesing the top and bottom by 3. And the effect that's going to have is this. Look, you see, we've now got two new fractions, but the denominators are the same. They're both out the same amount now. And so now you can just add across the top. 8 24ths plus 15 24ths is going to be 23 24ths. So that's how and it's the same thing with subtraction. You have to get the denominators the same first, and then you can just subtract across the top. So that's the one little extra step that we need there. Right. So now let's have a look at what are known as improper fractions. So what we've been looking at is proper fractions, where it is a fraction of a whole. So a whole being, like 1, and then a fraction is, less than 1. And that's what's known as a proper fraction. Improper is ones like this, or sometimes known as top-heavy fractions, where the number at the top is bigger than the one on the bottom. So this is actually greater than 1. And so we're doing this division, and say we might want to like break this up, take out how many whole parts there are and leave just the proper fractional part left over. And we've kind of seen a little bit of how this works in the previous lesson. So we have here, like when we did this division, 273 divided by 4, and we work it all out and we get a remainder of 1, that answer could then be seen as 68 and 1/4. That's an example of a mixed number where you've got a whole part and then a fractional part. So that's what we're looking to try and do here. So you see with this 14 over 3, you probably won't need long division for this. You could see the biggest multiple of 3 that's less than 14 is going to be 12. So we've got 12 plus 2 left over. Because 12 divided by 3 we can do, and then the 2 divided by 3 will do that, leave that left over. And it's going to come out to this. 12 over 3 is 4, and then you've got the remainder of 2, which is still to be divided by the 3, so you get 2/3. So that's an example of a mixed number. So let's take an example of how we do arithmetic with mixed numbers. So say if you got something like this, where you do 4 and 2/3 plus 2 and 1/5, how do we do that? Well, remember, 4 and 2/3 is basically just 4 plus an additional 2/3, and 2 and a fifth is 2 plus an extra fifth. So what we can do is we can rearrange that and just add together the whole parts, 4 plus 2, which is 6, and then add together the fractional parts, which we can do in the same way we did earlier, where you got to make the denominators the same, and then add across the top. And when you do that, you might want to try that yourself. You can always pause here and try that. You'll find it comes to 13/15ths, and put that together, and there we go, 6 and 13/15ths. So this is fractions. So we've got proper fractions and we've got improper fractions, and then how we can convert to, say, mixed numbers like this, where you got a whole part and a fractional part. So now let's move on to decimals. So a decimal number, so we can even regular numbers like what we saw last time, like this. This is still technically a decimal number. Because it's like part of that base 10 counting system I talked about last time. But when we say decimal numbers, normally we're referring to ones where they've got digits beyond the decimal point. So that's like this here. And how those digits work is kind of in the same way these digits work that we've already seen, units, tens, hundreds, thousands. Going in the opposite direction, we then get tenths, so that's 1 in 10, hundredths, thousandths, so that's 1 in 1,000, 1 in 10,000, 1 in 100,000. So you see, it's still powers of 10, but it's going down. Uh, so like using our indices laws like last time, this is like 10 to the -1, 10 to the -2, 10 to the -3, and so on. So we're still going in, in powers of 10, but we're going in the opposite direction, getting smaller and smaller. So now let's look at how we could do arithmetic, long arithmetic in particular with decimals. Now, when it comes to addition and subtraction, it works exactly the same way we did it last time. So you got to make sure you line up your place values correctly. So then the decimal point should be then, lined up as well. So you see we've got our units, then we have our tenths, which is where the 1 and 9 is, and then we've got the hundredths, which is where the 1 and 8 is. And then we just do the same kind of algorithm that we did before, where we do 1 plus the 8 is 9, 1 plus the 9, which comes to 10, but we're carrying that 1, 4 plus the 3 is 7, plus the extra 8, plus the extra 1, sorry, comes to 8. And then, yeah, we put that decimal point in the same place. So we get 8.09, and there you go. So the only thing we've got to be careful is more addition, not addition, sorry, multiplication and division. Like I said, addition and subtraction work exactly the same way. Multiplication and division, it's a little bit trickier. So first of all, let's take a look at an example. Like, say if we just try and do it the same way we did before, and let's see what happens. So I do the 9, I times it by the 0, I times it by the 5, I get 45. You're carrying that 4. 9 times the 3 gets 27, plus the extra 4 gets to the 31. And, so I put that decimal point in this, the same place as the others. Now we're going to the next number. We have to add a 0 first. Do 2 times that 0 on the 35.0, get 0. 2 times the 5 is going to get 10, but we're carrying that 1. And then 2 times the 3 gets 6, plus the extra 1 gets us a 7. And now we just add down the columns and we get this. Now, this probably doesn't look right, and it's not right, because 35 times 2.9, so it's like roughly timesing it by 3. 35 times 3 is going to be around about like 100 or so, but yet we've got an answer that's 1,000. So we can tell that's way off just by roughly looking at it. But it's like, okay, but why has that gone off? And the reason why it is because of that decimal point. Like when you times by a fractional amount, like the tenths column, that actually makes a number smaller. Yet when we're carrying things like carrying our 1 or our 4 there, we're carrying it to the left. It's like assuming that it's getting bigger, and that's where the mistake comes in. And so we can't do it this way. Instead, what we do is we do something like this, where we just ignore the decimal places. So we do 35 is becoming 350, 2.9 becomes 29, and we do the calculation as usual, and you get all the same digits because it's the same calculations, and the end answer comes to 10,150. So this is correct. This is 350 times 29. That's all correct. It works for whole numbers. Now what we do is we compare this to the calculation we actually wanted to do. So we didn't want 350, we wanted 35. So you see what we've done there, we've essentially times that number by 10. Likewise, we didn't want 29, we wanted 2.9. And so that number's also been multiplied by 10. And so we've got two numbers now that are 10 times bigger than they should be, and we multiply them together. It's producing a number that is 100 times bigger than the answer we actually want. So that 10,150 is 100 times bigger than what we actually want. So what we do is we divide that by 100. And so we see there, if I kind of just move my bubble, you see 35 times 2.9 is going to be 101.5. So take that 10,150 and move the decimal point 2 places, because that's divided by 100. Remember, like standard form last time we was looking at that. And there you go, we can get that answer. So that's the way we should do that with multiplication. Ignore the decimal places and then shift it later based on how you've adjusted the numbers. So let's try that with, say, a division quickly as well. So we've got this one, 502.36 divided by 1.9. We can do that division in the same way we did before, but you see we've got a 2-digit this time, but it works the same way. So we try and do that 50 divided by 19, which gets 2, with remainder 12, because we can't do 5 divided by 19. That 12 we can't divide by 19, so we bring down the 2 and do 122 divided by 19, which gets us 6, with a remainder of 8. We bring down the 3, do 83 divided by 19, gets 4, with a remainder of 7. Finally, we bring down the 6, do that divided by 19, so 76 divided by 19 gets 4, with a remainder of 0. So you see it works very much the same way. You just, sometimes you've got to take slightly bigger numbers because you're dividing by 2 digits as opposed to 1. And so, okay, we get this answer of 2,644. But again, you see what we've done here, we've essentially times that 502.36 by 100 to get, by getting rid of that decimal point, and the 1.9 we've times by 10 to get up to 19. So does that mean the final answer we've got there is 1,000 times bigger than what it should be? No, because we're doing division here. So if we take a look at it like a fraction, like this is what we're doing. We're doing 502.36 divided by 1.9, and we've times the top by 100, and we've times the bottom by 10. So we're timesing the end result by 100 divided by 10, which is 100 divided by 10 is 10. So the end result is we're multiplying the final answer by 10, not 1,000. So if we're if we know this answer is 10 times bigger than what we want, we divide it by 10, and you see we'll get this answer of 264.4. So be very careful of that. Like, it, how the answer is going to, change based on, us taking away those decimal points is going to be dependent on the operation you're doing. With multiplication, it's a bit simpler. With division, you got to, just take a little bit more care to be sure of, that you're moving it the right amount. and that answer seems about right, doesn't it? Like here, this is like roughly 500 divided by 2, which would be about 250, wouldn't it? So 264, we can tell it's roughly in the right place, so we can be confident this is right. That's something to do with approximations, which we're going to be doing in a lesson soon. So let's move on to percentages quick. Not much to say about percentages, to be honest, because it's more for presentation as opposed to calculation. So yeah, let's have a look at what that means. So first of all, what a percentage is, it's a proportion, kind of like a fraction, but standardized to be out of 100 as opposed to out of whatever the denominator is. So, and the kind of the clue is in the name, like percent, like cent as in century being 100 years, centipede having 100 legs, and so on. Cent means 100. And you can kind of see it in the percent sign like this. It's essentially out of 100. And you'll see that that'll be very useful later for when doing conversions. So the reason why we do this is because it makes it easier to compare proportions. So say if you've got two fractions with two different denominators and you're trying to compare them, it's hard to really see which one's bigger or smaller or by how much. But when you have two fractions, say if I've got 50% and 60%, well, you can easily see which one's bigger. So that's why we use it, and it's like for those presentation purposes. Yeah, like I said, yeah, for presenting like statistics, and not so much for doing calculations. So here's an example, like when dealing with fractions, like say if we're trying to multiply a quarter by a quarter, like we're taking a quarter of a quarter and we get 1/16, you can just multiply them together like that. And the same thing works with decimals. If you try and do this multiplication of 0.25 times 0.25, it will come to the correct answer. But it doesn't work the same with percentages. So 25% times 25%, well, 25 times 25 is 625, but that's not correct. That doesn't equal 625%. So yeah, percentages are more for just presentation. If you want to actually do calculations, you convert to one of the others. So we typically will convert to fractions. If you're doing things on paper, it's normally easier to work with fractions. If you've got a calculator, typically you want to convert to decimals. That tends to work better. So depending on whether you've got a calculator or non-calculator paper, that's the way you generally want to go. So let's look at the last topic is how do we do those conversions? How do we convert from one form to the next? So here's all the possible different conversions we could have between our three different types of proportions. So let's look at the first pair. So percentage to decimal or decimal to percentage. So it's going to be the same process, isn't it? But just in reverse. So let's look at, say, 63%. So like I said, percent, it's just per 100. So this is essentially just 63 out of 100. And once we've got that fraction out of 100, well, like I said, a fraction is just a division, isn't it? It's 63 divided by 100. And we can easily do that division because we're dividing by a power of 10. And so it's essentially like shifting the decimal place two places. So it's no coincidence that we've chosen to do it out of 100. We've done that because of the way our number system works. It's just a matter of shifting the decimal point back and forth. And so it makes it very, very easy to do. So that's how you would go from a percentage to a decimal. And vice versa. If you go for 0.17 like this, we can just shift that decimal point. So we shift it to the right, to get us up to a percentage. So 0.17 is going to become just 17, as 17 would go to 0.17. So a couple of cases you want to be aware of that can be a little bit more complicated, like something like this, where there's a bit more decimal places going on, but it's the same thing. So what we want to do is we want to times this by 100 to then make it out of 100. So if you times it by 100, you shift that decimal point two places, you see you get 8.04. Likewise, if you get something like this, where you got a percentage that is more than 100%, you're going to get a decimal number that is greater than one, like an improper decimal almost. You can kind of see it. But yeah, you see, it works the same way again. You're just dividing by 100. So that decimal point moves two places to the left. So that's that one. The next case is when we say we're doing percentage to fraction or fraction to percentage. So if we have a percentage like this, the first step normally is good to just put it like that. When doing most conversions. But if we're doing convert a percentage to a fraction, that's it. You're essentially done. But one thing you might have noticed is we can simplify that fraction. So as always, whenever you get a fraction, you always want to put it in its simplest terms. So here we can divide the top and bottom by 4, cancel out that common factor of 4, and we get 12 over 25. And you can see that's as far as you can go. So the other way round can be a little bit trickier. So say if we've got 3/5, well, we want to make it a percentage. So remember, a percentage is just out of 100. So what we want to do is get that denominator to be 100. And what I can do there is times the top and bottom by 20. So we get 60 out of 100. Well, that's just 60%. There you go. It can be a little bit trickier when you got a number like this because, okay, we want to get that number, that fraction to be out of 100, but 40, there's no easy number to multiply 40 by to get to 100. It's actually going to be some fractional amount, like 1.5 to be precise. 1.5 times 40 will get you to 100. But if you're not comfortable with that way of doing it, what you can do, sometimes it's better to take a step back before then taking, 2 steps forward. So in this case, taking a step back by simplifying it, divide the top and bottom by 2, so we get 3 over 20. Now 20 is a number we can quite easily scale up to 100. Like we just got times by 5. And so we times the top and bottom by 5, we get 15 out of 100, which is then just 15%. And you might notice, yeah, like I was saying at the start, if you multiply the top and bottom by 1.5, 40 would go to 100, 6 would go to 15. If you can see it that way, you could potentially jump that in one step. But there's no need to do that. Doing 2 steps is perfectly fine. But ultimately, that's what you need to do. You need to get that denominator to 100, and then you can just read off the percentage on the numerator. Now, finally, what can often be like the trickiest one, decimals to fractions or vice versa. So say if we have the decimal of 0.4. Well, to put that as a fraction, we can write it like this because you think about it, like think of it as like just like a division. Like if you do 4 divided by 10, it's just shifting that decimal point 1 to the left, and so it then becomes 0.4. So we kind of need to think of that in reverse. So we've got 0.4. If we keep shifting that decimal point all the way to the end, you're then going to produce a whole number, and that will then be your numerator, and then put the appropriate power of 10 on the bottom. So 0.4. If I move it 1 to the right, that's essentially going to put a division by 10 on the bottom, and the top is going to be 4. And then, as always, you just simplify that fraction. With a 2 decimal place decimal, it's going to be the same thing. Okay, now but we're shifting it 2 places. Should we shift the decimal point 2 places to the right? We get 64, and then divide by 100. So you can see that I've used to calculate that 64 divided by 100, it would become 0.64. And again, you just simplify that fraction. And we can even go one further. Like you're probably not likely to come across this so often, but say if you've got 3 decimal places, it was going to be the same thing. You're just shifting that decimal place 3 times. So it's going to be 1,025 over 1,000 this time, 3 powers of 10. And it might be a bit harder to simplify that, but you'll find that simplifies to 41 over 40. Might need a calculator for that or something. But you see, it's the same idea. You just need to see how many decimal places do you need to shift before that number will become whole. And then that's going to essentially be your numerator, and then you're just dividing by the appropriate power of 10 on the bottom. You see here for 1, 2, or 3 decimal places, this is the way it'll work, and then you just simplify the fraction. Right. Okay, so that's it really. So let's finish up with fun. Did you know? Some of this stuff you might encounter in GCSE, but potentially not. It's a bit more sort of higher level math. So like we have other types of decimal numbers that have an infinite number of digits, like say pi, for example, is something you're going to encounter at geometry, all to do with circles and things like that. This is a number that goes on forever and it never repeats. It just has just new digits just going on forever. This is what's known as an irrational number. And like we've seen fractions like this, say 1 over 8 is 0.125. It's so many decimal places then stops. You can get other fractions like this, say 1 divided by 3 becomes 0.3 recurring. So it just repeats 3 over and over again. And so we can put that in this more compact form of 0.3 dot. And that dot represents the recurrence, 3 repeating over and over again. But then you can get other numbers like this, 1 over 7, where that repeating part can be a lot longer. Like you got 1, 4, 2, 8, 5, 7, which repeats over and over and over again. And these are examples of what known as rational numbers. So you got this decimal expansion, but it goes on forever, but it repeats, unlike the irrational number, which is pi, which doesn't repeat. It just goes on forever with just new digits. So here's some other interesting types of number that you may or may not encounter. Right. So leaving it there for today. So here are your takeaways from today's lesson. Next time we'll be continuing with numbers. This time looking at some of the things I mentioned today, like approximations, rounding, and then managing those errors due to those approximations and so on. Right. So I'll see you there.